Welcome to the Tech Community Day. We are at the next session is WSL2 and Docker to develop embed Linux containers apps. We have with us a real pleasure to have Hayden Barnes and Mateus Costello. Um, well, I'm going to go really fast to not to steal so many time. So uh, this event is brought to you by the communities, some communities of Guatemala, SQL Server User Group, Microsoft Dev Coban, Docker Guatemala, and Kubernetes Guatemala. We have uh, made the efforts to collaborative efforts to brought all these these sessions today. Um, this is the social network for today. This is the Tech Community Day. We are at the page, the Facebook page, the Twitter, and the YouTube channel. Please follow it, and you will find a lot of content there, and you will enjoy as us. um, we will. You can. We will track all the questions through the YouTube channel and on the Slack channel. We will. You can raise all the questions you need to the speakers. We will address them and read them to them at the end. So you please feel free to participate and be with us today. Thank you. And as always, the Q&A part will be at last to address all the questions. Um, so this is the next session, but I'll put it later. So this is the Tech Community Day, and without further ado, here's Hayden Barnes and Mateus Costello.
Thanks so much, Carlos. My name is Hayden Barnes. I'm a senior developer advocate with Canonical on Ubuntu on WSL, and I'm joined today with Matthias, who is a community member and blogger, and we will be presenting on using WSL2 with Docker for embedded development. I'll start off with a little background on WSL, and then we're going to transition to Matthias, who will be walking us through some very interesting demos on cross-architecture development. That is actually building on x86 and then deploying to ARM64. But what is WSL? WSL is short for Windows Subsystem for Linux. It is essentially a Linux terminal in Windows. And Carlos, could you show? Here it is. Unlike a virtual machine, WSL launches in under 2 seconds. And it gives you a choice of distro from the Microsoft Store. Being from Canonical and working on Ubuntu, of course, my preferred is Ubuntu. But all the normal packages and Linux applications that you can download on Ubuntu Server and Ubuntu Desktop can be downloaded, and most of them run on WSL. So why do we do this? Why have Linux on Windows like this? Well, one, what I touched on before, which were packages from all of those distros. You have an entire universe of tools, libraries, and source code that you can build your applications and solutions from. Things like a LAMP stack or .NET or even Node are all cross-platform and can be used on WSL. Even things like containers, which we'll see later with Matthias on Docker, but also Kubernetes, things like microkates and other container formats like LXD can be used on WSL. So how does this benefit your workflow? One example would be using the Visual Studio Code extension for WSL, which I will show. Of course, we're all familiar with Visual Studio Code. It's been out 5 years now and is growing more popular. The extensions at this point almost make it a full-featured IDE, but The extension in particular is this remote WSL extension. So I have Ubuntu, as you saw before, running on my machine, and I have code here, and I have the extension installed. You can see I'm remoted into that down here. Let me see if I can find a way to zoom. I don't think I can. But one thing I could show you is when you're remoted in and you open a folder, it's going to open that directly on your WSL image. So I think I just accidentally opened my entire root folder, but this would be a great example for the folks watching. Yep, there it is. There's my whole WSL Linux root folder in all its glory that I accidentally opened. Here's my home folder, and here is my work environment, my SSH keys, projects I've been working on and downloading. So this allows you to code in Visual Studio Code and interface directly with your code hosted in the WSL environment, containerize it, and then using like public cloud CLI, something like Azure CLI, pushing directly to the cloud after testing and debugging directly on your machine. You can even open a terminal in code, and you get direct access to your terminal. You don't even have to move out to the other terminal application that's available. So other cool things you can do with WSL. You can integrate it with Visual Studio. Visual Studio has C++ Linux workflow available that can be installed. And then you can run and debug C++ Linux applications from Visual Studio. We found this particularly helpful among gamers who have been using Visual Studio and C++ in particular for a long time, but want to deploy to Linux or build part of their gaming application in Linux to support online multiplayer. But the other advantage is those native Linux tools, not just integration. But let's go back to my desktop here, my terminal. And you have everything here that you would expect on a Ubuntu server. And if this is new to you, if Linux is new to you, that's even better, because this is a great way to experience Linux without having to set up an account, worry about leaving a VM running and running up your cloud bill, or let's just say you don't have extra hardware that you want to install Linux on. This is a great way to get started, and you have everything you would need to start building. Everything from the basics like Nano, which is a very simple text editor, all the way up to something like Emacs. You would install, you would run in Ubuntu, you would use the apt package manager. So you do sudo apt install Emacs. And it's going to download some dependencies. And we will have a fully extensible Emacs client from Ubuntu 2004, the most recent LTS version that we can run on Windows. Now, you might ask, can we run GUI apps? And the answer is yes. You can use GUI apps currently with a third-party X server, something like VCXCRV or X410, which is a paid app from the Microsoft Store, and run those GUI apps. A little configuration is required, but if you need those steps, you can check out the WSL page on the Ubuntu Wiki, and we have those commands that you can use to launch those GUI apps. Later this fall, we expect some news coming from the WSL team at Microsoft on native GUI applications, so that a third-party application X server won't be required. But coming later this month, we are expecting GPU acceleration for GPU compute workflows like AIML and artificial intelligence, machine learning that are really going to take WSL to the next level. You can already deploy a Kubernetes cluster with microK8s on WSL, and now you'll be able to deploy TensorFlow, in Kubernetes on WSL before deploying to the cloud, or if you're lucky enough to have a cluster of mainframes of your own to power them. A few things you need to know. There's actually two versions of WSL, WSL 1 and WSL 2. WSL 1 has been out since about 2007. It's a binary translation layer. It actually runs the Linux binaries, translates the Linux system calls to Windows system calls, and executes them. It's very stable. It's got about 95% binary compatibility with Linux, so there's still some edge cases that you run into, but that's okay because Microsoft released WSL 2, and it just made it into the May 2020 update of Windows 10. So it is now in stable release, and WSL 2 features a virtualized Linux kernel. It is a Linux kernel that is actually updated via Windows Update, but you can go look at the sources on GitHub and see the customizations that are made to work in WSL, and it is much faster. You can even build your own kernel if you'd like. That's something Matthias, my co-presenter, has done and has a great video on. But WSL 2 unlocks a lot of new opportunities performance-wise. The new Docker desktop, as we'll see, uses WSL 2 on the back end. It actually hooks into WSL 2 and uses it to power the containers. And those changes have also landed in stable in Docker desktop. And that's very exciting as well. So we've covered why you might want WSL, which is the access to the massive repositories of open source tools and utilities that you can now integrate directly into your workflow, even on Windows. We've talked about leveraging that and open source. Some of the interesting workflows I've seen include Node, .NET, embedded, as Matthias will be showing. Also seeing things like software-defined radio, FPGA programming. Very exciting stuff. There's some limitations to WSL. There's no external hardware support. So you're not going to be able to plug in third-party devices like to USB. There's no init process. I think there's a cat outside. I really hope you guys can't hear that. Anyway, it's making it hard to focus. But there's some limitations. There's no hardware support. There's no init. And so you're going to have to manually start your services. If anything has a really hard dependency on systemd, like you're probably not going to be able to start your whole GNOME desktop. Mate, sure. XFCE, yes. If you really wanted to run a Linux desktop next to your Windows desktop, you definitely could, but probably not full GNOME. You have the code extension. You have Visual Studio integration. Also, a fair number of JetBrains IDEs, not all of them, but some of them do, have integration with WSL. And you should know that WSL 1 is good if that's what you have. WSL 2 is even better. There's some compromises between the two at times. WSL 1 is a little lighter. WSL 2 is more performant. But you definitely need Windows 10 May 2020. Okay, I think the cats are done. To keep going to get WSL 2. So, and then Docker Desktop for WSL2 uses WSL2 on the back end. And with that, after I've been thoroughly distracted by the cats outside, something I don't usually have to worry about when presenting at conferences.
We have a question if you want to address
Sure.
it or at the end, because while we wait for this, so
Yeah,
I
this
have
is taking a while. I should be on my faster computer, but yeah, let's take it.
no,
Let's drop it
that's
down.
fine. Just let me change this layout
Oh,
for a moment. George is asking us, can I transfer files between file systems?
yes. So let me show you real quick. There's two ways to do that. Let's just open a new. All right. Well, that's going. So right away, you see your C drive is mounted at Mount C. So all of your C files on your C drive are going to be accessible this way, including your, your program files, your user files. They're all there. Now, if you need to access them from Windows, let me show you this. Make sure. There we go. You can access them in Explorer and even mount internal WSL folders as drives. There we go. With // WSL $, and then the name of your distro. Or if you have multiple distros, they would all appear here. But I have Ubuntu. And you click here, and you have all your files. So you can access your files either on the Mount C folder in WSL or in Explorer using / WSL $/ the name of your distro. So I generally recommend, for performance reasons, anytime your files cross the file IO boundary, it's going to be a little bit of a bottleneck because it's having to translate them between Windows and Linux formats. But if you keep them all on your WSL image and access them as needed from Windows using this Explorer, you're going to see a lot better performance. So if you really want to take advantage of WSL2, I strongly recommend keeping those files on the WSL image and accessing them this way. And keeping them backed up, pushing to Git as needed, or mounting them as a drive and backing them up offsite. Any other questions?
Let me take a look. Yeah, there is a few questions here. There you go.
Let's pause. Let's pause and transition to Matthias for his demo, and we'll pick all these up at the end. So if we need to go over, we can finish them in the Slack channel as well.
Of course, that's great. Yeah. So I am turning over to Matthew here.
Let me share this screen here. Share it. You can put it in yeah, it's okay. So I'm using here the WSL. I'm using the Ubuntu 20.04 on my Windows terminal here. And first of all, I will show you guys the problem that we have to develop for the embedded device. As Hayden talked about, generally we have environment development and development environment we use x64 architecture, Intel architecture, and the target device have us a different architecture. So here I am using the WSL, and I have here, oh no, here. Let's cross. Here I have this simple hello.c. As you can see, is a simple hello tech community day print. This will output on the screen this message for us and will exit the program. So to compile it is very simple. I have here, I'm using the distro inside the WSL. Oh, let me show. I'm using here a real kernel Linux, right? As Hayden talk about, TWSL2 uses a real kernel Linux inside the Hyper-V from Microsoft. So here we have the kernel Linux from the Microsoft standard. You can also compile your own kernel Linux. You can get the source code from the Microsoft. You can access the GitHub from Microsoft and clone this Git repository with kernel source code. And also you can clone the source code directly from Linux torvalds, from the Git repository from Linux torvalds, and compile the latest mainline kernel Linux for the WSL2. But today I will use the Microsoft standards to not have any issue here with the demos, okay? So the default and the default is use the Microsoft. If you have some feature that you want to add on your WSL that needs to recompile your kernel, the better is get the code from the Microsoft standard and compile it with this driver or feature configured, okay? So here I have the GCC compiler, and I will output here the hello binary from our hello.c program, as you can see here. And I can execute this without problems. We can see here the output, hello tech community day. But we are developing for embedded devices, right? So I have here on my desktop this board here. This is a Toradex Apalis IMX6. This guy have quad-core ARM Cortex A9 32-bit processor. Okay, so and this is connected on my local network here. So I can access this board through SSH. Let me get here the IP address from the board. So, SSH. So here I am on the Apalis dev board. You can see here I am accessing the bash from the dev board. Okay, so I can use the SSH to copy this hello binary to the board. So let's do it. I will copy the hello binary for my default user folder. Password, and it's done. Let's access the bash again on the target device. And now, if I try to execute this binary here on my target device, you can see that you do not work because the bash is telling here a tip for us, a clue. Cannot execute binary file, exact format error. Of course, I'm trying to execute a binary that is compiled that have instructions for Intel architecture on ARM hardware. So this is not possible. Here on Linux, on the WSL, we have this file utility from Linux that describe the header of a file that we pass as argument. So let's pass here the hello binary to the file, and you can see here that this file is an ELF 64-bit executable for x86 64 architecture, for Intel architecture. So To develop for embedded devices, we have to cross-compile our applications. And for this, I already have here installed. I have on cross-compiler. This guy here is the ARM Linux GNU GCC. This guy will run on the Intel architecture, but will output instructions. You output a binary for the ARM architecture, for execute on ARM hardware. So I will make the same here. I will use the GCC, but for ARM, the cross compiler. Output here the hello ARM binary from the same source, the hello.c. And now I have the hello and hello ARM files. So I can check it now, the description, the header of our hello ARM file. And you can see that now we have a ELF 32-bit executable for ARM architecture. So now if I copy this guy to our target device, let me get here the IP address. Done. And access, we will access again the bash on the target device. Oops, yeah. So now we have also here the hello ARM binary. And now this will run because now we have the correct instructions, we have the correct header, we have the correct binary format to execute on our ARC hardware, on our ARM hardware, okay? So this is the basic here for embedded development, for Linux embedded development. Generally, we have development environment that have architecture different from our target device, okay? But let me show other thing here. On Linux, we have this LDD. This guy output for us the shared objects, the libraries that we have linked on our binary. As you can see here, hello is a very simple binary. We have only 3 shared objects, and this shared objects, these libraries, is the basis, the libc, and the basis to run a Linux binary. Okay, so it's a very simple binary. The problem on the embedded device, for example, my board here, this guy have 2 GB of RAM, but have only 4 GB of storage. So this guy is not running a full distro with a package manager or something like this, because we don't have storage to waste. Okay, so all the things that we need to run the application, it's only that we will store on our memory storage. Okay, so usually embedded development occurs, you have the application and we have to build from scratch everything for the target architecture to don't waste this storage. You compile from scratch only the binaries, only the dependencies that is need for the application. Okay, so let's get another demo here. Here I have a .NET. Here I have a simple .NET program, a console program. Okay, this will print on the screen for us the runtime information, the architecture of the .NET runtime is running, the description, the operation system description that our .NET runtime is running, at the end the hello world. So if I run this here on my development environment, and now I'm using the PowerShell here, to use the .NET on Windows, we will have the output here that I'm using here on x64 Intel architecture, running on a Microsoft Windows 10 and Hello World at the end. And the .NET have a cool command to cross-compile. It's a kind of cross-compilation. To .NET CLI here, we can publish. You can pass this publish command and pass also the runtime that our application will be published. So here I'm doing a .NET publish for the Linux ARM architecture. So this will create the binary for the Linux ARM. This will cross-compile my application for Linux ARM. And also this will create a publish folder. Let's, here, you can see Bing debug, netcore, Linux ARM publish. This folder here, let list. This folder here have a lot of DLLs and shared objects that the .NET runtime needs is dependencies for run the .NET runtime on Linux. So the publish command do this, cross-compile this for the Linux ARM if you pass the runtime TR argument, and also create a folder without dependencies to run this. But it's the dependency that .NET thinks that we do not have installed on your distro. But this is not true for embedded devices, and I will show this. Let's back here to Ubuntu, and I will access the board again. I already have copy all the publish folder here, okay, to not waste your time. And you can see that here we have all the DLLs and shared objects from our publish. And also we have the .NET Core creates here the binary. And you can see the binary is a ELF32-bit executable for ARM architecture. So we can execute this here on our target device without problems, right? But not, because we are missing yet one package, the libicu. The .NET thinks that this lib is a common lib and do not ship this on the publish folder. So, and here on my target device, on my distribution here for embedded device, I don't have this library. One of the options is get this library, get the source code of this library and compile it, cross-compile it for the ARM architecture and install on my distro, or make a distro from the scratch, compiling this library, or getting this library from a package manager from Ubuntu. For example, I can apt-get install from another architecture, but this is a mess. So the solution, the solution that we have on the Docker side is, okay, the only thing that you need to run, and the only thing that the only dependence that you need to have on your embedded device is Docker. So I have here on my distro that, oh God. And I have here to Docker, right? You have some images here for other demos. As you can see, the Docker is running well. So the idea is you have a distribution with the minimal need to run Docker, the dependencies to run Docker, right? And we will distribute your application inside a Docker container. So let's solve the problem of the libicu using Docker here. I have here the Docker file for our console program. I'm using the multi-stage Docker, and here we have the build stage. I'm using a common .NET Core SDK, and this is running on my Intel x64 architecture. Okay, this will copy the project, the source code, the project for inside my container, and will run the .NET Restore, the .NET Build, and will publish our application for Linux ARM. This will do this cross compilation for us. With this done, we have another stage, and this stage is important, and we have to take attention here, because as you can see, I'm using our ARM 32v7 Debian image as base. So this is very cool when we are developing for Docker on embedded Linux, on ARM embedded Linux, because we can create images, we can create ARM architecture images for our containers using the Intel environment here, using our development environment, using Intel architecture. So here I have a container that is running Intel, and here I have a container that is running an ARM architecture. This is very cool. So I will change here this hello world for hello tech community. Yeah. And I will build this Docker using the WSL here. So here on my WSL, I have the Docker running too. As you can see, I have a lot of images already pulled here on my machine. And this, and here I'm using the Docker desktop. Now in the latest version of the Windows to Windows 20 04, the latest version, we have this Docker backend, the Docker desktop using the WSL as backend, the WSL2 as backend. So let me show here. I have the Docker desktop settings. And another cool thing is Microsoft is shipping this lightweight Hyper-V with WSL2 also in the Windows 10 Home. So I'm using Windows 10 Home here, and I have the WSL integration here. I'm using the WSL backend, and you can see that I can integrate the Debian and Ubuntu distros from WSL to use the Docker commands. So let's go to my Windows folder here. My Windows user folder, documents, tech community. I will share this on my GitHub too. I will share the link. So it's hello. So let's Docker build using our Docker file, and I will tag this as my Docker Hub user here. If I'm not, it's .NET, it's .NET hello. Okay. Oh God. So this will build our Docker file here. You process the two stages for us, the build stage and the deploy stage. On the deploy stage, you can see here the library that we do not have on our distribution, the libicu. Okay, so this will solve our problem with the libicu dependence. And this is another cool thing too. I'm using the previous stage, the build stage here, to get the publish folder. So this .NET publish runtime Linux ARM will create the hello binary and dependencies, and we will store on the publish folder. And I can get these artifacts, this publish folder, from a previous Docker build stage. I'm passing here from, so you can see here that we can tag these stages. We can set names for these stages. So here I'm copying the publish, the project being blah, 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 Linux ARM publish folder from build stage. Okay, let's see if your Docker build is running. Okay, restoring this. Let's go. Okay. Create the first build.
Really quick question, Mateus. Would you like to take the question at the end?
Okay.
Can you hear me okay?
Yeah, you're hearing me?
Yes, we can hear you. No, I was asking if you
Okay.
would like to take the questions at the end, or you would like to do a couple now, because what this is
Yeah,
building.
cool. Yeah, I can answer now.
Okay, Carlos, I think you have a few questions there.
Okay. First, we have some of the questions from the beginning. I think it was David Ayala who asked, "Can I relocate the virtual HD of WSL2 to another drive?"
Kind of. It's kind of hacky right now. So the best, you can do WSL.exe --export, and you get a rootfs tarball that you can back up, that you can put on bare metal Linux and DD to a, which is image, to a boot disk. There are people who are accessing the VHD and doing things with that. It's all pretty hacky right now. So in terms of backing up, I recommend either backing up with that export command or using a third-party tool like Raft, which is a utility for managing and backing up WSL instances, similar to Kitematic, if you knew Kitematic.
Right. Definitely, Kitematic will assist you in a
Guys,
good way. Yeah, Mateus.
are you execute the Docker push here, and we can continue with the.
Yeah. Okay. Ready for you.
Ready. Yep.
I'll put on mic.
Oh, sorry, my mic is muted. So I'm doing the Docker push here to my Docker Hub account, and it's done. So now we can access again our board and pull this Docker image to our system. So let's Docker pull .NET. Oops. So this will get. I'm already done this once to test. So this will only update the layer that we changed. Yeah, you can see that we have two layers that already exist. and one that is updating. Okay, extracting. And after this, we can run our application to see this running with the libicu issue solved. Let's go board. Okay, we have a newer image, and let's .NET Docker. Let's Docker run here. I will remove this on the end. I will run this interactive. Oops. .NET hello. And as I'm using here the Debian ARM image as base, so you can see that we are running here on our ARM. The .NET runtime is telling us that the runtime is running on an ARM architecture and on a Linux 5.4 and Hello Tech community. Okay, so we used the WSL to make a multi-stage Docker build here using an Intel image, an x64 image, and deploying it on a container, on a Docker image for ARM32. This is very cool. Let me show here. This is possible because on the kernel Linux, we have the QEMU, and the QEMU, you emulate only the user space for us. So all the syscodes will be run on our kernel, on our native kernel. So here, let me show here, because WSL. Let me list here. Whoops. Let me list here the WSL distros that I have installed here. I have the Debian that is running on WSL2. I have the Docker desktop. That is the data for the Docker. And this is the distro that runs the builds for our Docker. And you can see that's run also the WSL2. This is installed when we install the Docker desktop with the WSL2 backend selected. Okay, so we can enter here on this distro. Let's execute here this distro, and I want to show here how this is possible. How I can run here. I'm inside the Docker desktop distro that runs or builds, and I want to show how it's possible to run this QEMU inside. We are running our ARM32 architecture inside the Intel 664 x64 architecture, because we have this guy configured here on the Docker desktop. Is the proxies fs bin format. Yeah. You can see that we have the QEMU ARM, the QEMU X, blah, 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 the QEMU ARC64 for ARM64, the ARM V8 architecture, PPC. This is the architectures that we can run using the QEMU and using the Docker desktop. So if you have some image, some base image that needs one of these architectures, we can build it using the WSL2, because this using the WSL2 and the Docker desktop, because this is already configured on the Docker desktop distro. Okay, So nothing's magic here, okay? So we have time yet? How is our time? Hayden or Carlos?
Yeah, we've got about 10 minutes left, and we've got some questions.
Yeah.
Yep.
That's
Uh,
correct.
One that is great for you, because I know you tested this, Matthias. What is the performance impact on Docker Desktop versus Docker Desktop with the WSL2 backend?
Oh, this is good. I have a blog post about this, and I tested some benchmark scripts for this. Using the WSL1, this is a crap. The WSL2 is better.
Yeah.
The full Hyper-V, the full Hyper-V is not so slow, but we have a minimal. Let's see if I found here this blog, because I can show on this screen the
Yep.
charts.
And that's the other advantage of using the WSL2 backend with Docker Desktop, which is before, if you wanted to use the Hyper-V backend that was fast, you had to have Windows 10 Pro, Enterprise, or Education. But now you can use the WSL2 backend on any version of Windows 10 that supports
Yeah.
WSL2.
Yeah, I remember I watched some benchmarking from Craig from
Yeah.
Microsoft showing the difference between the I/O from WSL and WSL2, and the jump is it's amazing.
It's 20 times faster on the.
Yeah. It's really different.
Yeah.
So this is the I/O is 20 times faster on the WSL2. For CPU, don't have much difference on the Docker desktop with full Hyper-V. We have better CPUs, but it's not much. And we have all tests. Oh yeah, so it's CPU, TIO. Yeah, this is. We have more questions.
Yeah. The other question was that I know of. Was does the Raspberry Pi and .NET Core support all the GPIO pins?
Yeah, support.
That one's for you.
Yeah,
Spanish
we
is
have.
good, Hayden, by the way.
Yeah, it's very good.
Yeah, very good.
Yeah, we
Go
have
ahead, sorry.
we have support for all the GPIOs on the Raspberry Pi using the .NET Core. We have the .NET IoT project from the .NET Foundation, and this you can use all the GPIOs.
Okay. I just wanted to ask you, because I got questioned with your lab that you did there. You can emulate the same using a different distro, like Raspbian or something like that, or cannot do it with Raspbian
You
interface.
say on the hardware side, right?
Right.
Yeah, you can. It's the only thing that you need is the Docker running
Oh,
on
perfect.
the.
And the other part of the question would be, what is the the limitation? I mean, if you can use Raspberry Pi like version 2 B plus or something like that, or what is the minimum that you need?
Yeah, this will depend on the port of the Docker and Go. I think we have for ARM v6 too. I'm not have sure. I have sure by the Raspberry 2, Raspberry 3, and 4, because it's ARM v6 and ARM v7 and ARM v8.
Okay.
For ARM v6, I think that we have to the Docker ported for ARM v6.
Oh, thank you for asking for answering that. I just had like curious there. I don't know if there are any more questions.
There was a follow-up from David, it looked like,
Right.
about space
That's
issues.
correct. Yep.
And I think
Yeah.
I misunderstood his question before. I think before he asked about moving the VHD file, I think what he's talking about is generally where can you stash your WSL distro. If you install through the store, you can set a drive in Windows, and it kind of works. What I would do instead is manually import the distro using the wsl.exe --import, and it lets you set a folder for where you want to unpack the distro to, and that is how I would install it. Now that has caveats. You're not going to get a desktop icon or a start menu icon for that because you're side loading it. But if you download the new Windows terminal from the Microsoft Store, it will still be available in the drop-down box in the Windows terminal. So if you're worried about space, I would side load and use that import function, and then point it at an external drive. Your mileage will vary, which means you may run into issues not running it on C that I've seen before. All right. Any other questions from YouTube?
Not for the moment, I think. Yeah, you have
Yeah.
covered pretty much.
All right. Well,
got it.
Yeah, they're just happy that the question was answered. So that was,
cool. Well, that was a great demo, Mattias. I really appreciate it.
Yeah.
Doing some cross-architecture stuff with Docker there. That's really nifty.
Yeah.
And that's just one of the examples you can do with WSL. It's kind of like a pie in that here's this thing that we give you, and you can build what you want on top of that. You can build your development stack. You can, use Docker and push containers different places. You can manage your cloud. So I really invite the community to try it out, enable it. If you need help, check the Ubuntu wiki page for WSL. And you can find me on Twitter at Unix Terminal. And
That's a cool.
Yeah. Name.
And Mattias, do you want to give your social?
Yeah, please do. Or put it on the chat, and we will.
Yeah.
Twitter handle. Yeah. It is at Unix Terminal, right?
Mm-hmm.
There you go.
And find Mattias on YouTube under Micro Hobby.
Micro Hobby. Yeah.
Yeah.
Perfect.
Lots of good videos.
Yeah, excellent.
If
I'll definitely check out there.
Matthew, if you don't mind, if you can just give us your YouTube link, that would be great, so we can put it here in chat.
Let me get him.
Yeah, I'm trying as well. Micro Hobby. That's what you said.
It's Micro Hobby Brazil.
Oh, Brazil.
Oh, Brazil. Yeah. Greetings to Brazil. Yeah. Hayden, I have a question for you.
Mm-hmm.
Why will you recommend the audience to start working on Ubuntu? And because there are some people that is transitioning right now. They were probably .NET developers on Windows for a long time, and now with .NET Core, with Docker, and all this thing happening right now, and being Ubuntu, I would say the platform of choice at this point for many of these development workplaces, and also for run places and everything else. Why you would recommend, and why Ubuntu is so important in this ecosystem?
Well, Ubuntu is kind of the glue that holds it all together, because it runs on WSL, it runs on public cloud. If you open up Azure Public Shell, the default is Ubuntu. So Ubuntu is the most accessible. It's There's a lot of documentation, a lot of other users and resources available. The repository of packages is very full. A lot of third-party tools that get packaged in there as well. So Ubuntu is, in particular, is very useful to learn. If you pick up any, of the Azure certifications, particularly like Azure 103 or Azure 104, the administrator certifications, the book's Ubuntu. I mean, there's some PowerShell in there too, but it's mostly learning Ubuntu. So if you're going to be working on the public cloud, where the default is Ubuntu, if you're going to be working in containers, you're probably going to be working on Linux, and you're probably going to be using Ubuntu. So this WSL is a great way to get started on that. Without overhead of buying a second machine or setting up an account, Ubuntu is the most popular WSL distro. There's a few others, but we just have the most experience with it, and we consider it a very kind of important part of everything, Linux, because we provide Ubuntu for desktops, servers, IoT, all these different platforms, and we just see WSL as another one of those platforms. And if you get into Ubuntu that way, we're happy, because we want more people to use Ubuntu. I think you might be muted, Carlos.
I'm sorry. I was just saying compliments to you, to your presentation. Really, it was great to have you here. The people is like thanking you.
Oh, thanks for having me, and thanks for Matthias for joining me and showing off some cool demos. I couldn't have done it without him.
It's a pleasure,
Definitely.
guys.
Yeah, I'm really curious with what you can do with the ARM system and everything there. So I'll definitely check it out. So I think that there's I'm sorry.
One cool thing is because we are using embedded device, and some guys are migrating from the Windows side, from Windows Compact Edition, I think, from the embedded sides to Linux. So these guys are used to use Windows, the desktop environment and everything. So use the WSL is a cool development tool to migrate, to make this migration more easy to these guys. So.
Really? Yeah, definitely. Just the last question, I think that from the public is if you can share your GitHub, your presentation or material on it. I don't know. Yeah, or you can put it on Slack. I don't know. There's no problem there. So if you have it there, well, that's okay.
Yeah, I'm here on the YouTube too, so I will paste on the comments.
Okay, perfect. Okay, well, thank you guys for being with us today. And it's exciting what we can do with what you can do with the platform, and the people is really happy to have you here. Thank you very much. If you can stay on Slack, we can, like, if there is some people that can thank you for over there, we can like chat over there.
Absolutely.
Okay.
Thank you so much.
So we are wrapping up right now and ending the session. So thank you very much to everyone for being with us today, and have a great day. Bye-bye.
Bye.
Bye-bye. Thank you.